Hey guys, and welcome back to a new video and a new playlist. You wanted it, you will get it. A playlist about Material3 Expressive, so the new extension of our existing Material3 theme on Android. In this playlist, I will go over all those very important changes that it brings here in more detail than I already gave you in the overview video, and we'll mainly get into all those new components that it brings, or those components where something very crucial has changed. However, before we even get into the new components, we need to get into the completely new motion physics system that it brings, because that is one of the most fundamental changes that this new variant or this new extension of Material3 brings, which is in the end all about new animations. Because in the end, in case you're not aware, Material3 Expressive is, as I mentioned, an extension of the existing Material3 theme, which brings a few new components, which has changed a few existing components, but which also comes with more, let's call it vibrant animations, which should overall lead to a more alive feel and look of your app to your users. And these new vibrant animations this entire new extension is based on, we will take a closer look at in this video. If you want to follow along, then you actually need to specify a Material3 version, specifically an alpha version as of now. Maybe you're watching this at some point in the future where 1.5.0 is already stable. Then you can also use this, but at this point here, libs versions, your version catalog with all your versions and dependencies, make sure that you are using an alpha dependency here with 1.5.0 for Material3. And that should then, of course, be linked here for your Android composed Material3 dependency. This should already be there by default, but by default, this BOM here is probably linked and not the explicit version, so you may need to add that manually. But then let's get into motion physics and animations. Let's first of all take a look here at the official Material3 website, where they have compared those two new types of animations. On the one hand, Expressive, which is the new type, and Standard. So if you take a closer look here on the Standard animation, then yeah, it's a pretty normal animation, starts here and ends immediately at just the end of the animation, while the Expressive animation, if we take a look at the circle here, has a slight overshoot. So take a look at this white trail. It overshoots a little bit, and that is pretty much the biggest new change of this Expressive animation system here, that all of these animations have that little bouncy overshoot effect, which is closer to physics. And that is why they decided to make this the standard. You can, however, still decide which of these types of animations you choose, of course, also for these expressive components. And that is what we'll take a look at here, because the way they solve this is quite interesting, because you may already be aware with the normal Material3 theming here. So if you take a look in your project hierarchy UI, you have this theme package that is there by default, and theme KT, in which your color scheme, your font scheme, your shape theme possibly is set up. And down here, you have this call to material theme, to this composable, that then applies your color scheme, typography, and so on, and will then just serve as a wrapper that your entire compose UI is wrapped into here in your activity. However, this new Expressive theme brings one important change, and it makes this animation system actually part of your material theme, so of this piece of composable. This means we can go in here, and we now have this MotionScheme parameter that we can optionally set here. And here we can now decide about using MotionScheme.expressive with the new bouncy animations, or Standard. And if we choose Expressive here, and we need to opt into this experimental APIs here as usual on Android, Alt-Enter and add this to your theme KT file. But the advantage of defining this here is that this chosen animation scheme will then apply project-wide. So you have consistent animations across the project, depending on which of these animations you prefer. If you say, hey, I don't like these bouncy animations, well, then you simply set this to Standard, and all those Material3 expressive composables and new components will then use the standard animations. This way, they will have this bouncy effect, which Material3 expressive in the end comes with. So what this means is, if we, for example, now go into our root package, and we create something like a motion package in which we just play around with that new system a little bit, make a new file, motion physics maybe, file, make this a composable, motion physics, maybe demo, don't need a modifier here. And then let's say we really just want to have maybe a red box that we animate, that we scale up, and this scale up animation we then want to do with this new expressive scheme. And then we can simply have this box here. We give this a modifier to assign a size to it. For example, well, let's say 100 dp, give it a background color of color compose UI graphics.red. And then we can simply have some sort of state that will toggle our animation. So for example, is scaled down by, remember, mutable state of. Initially that is true. I'll enter to import this delegate here for this state. I'll enter again, and then we can define our animation state, which now of course works with all the various animation APIs that Compose brings. I will use the animate float as state API here. So we'll just animate a float value between 0 and 1. So 0%, 100% of our scale animation, which is usually the easiest way to animate anything, since you can just animate a percentage and that you can translate into any type of animation. So we can say animation progress, for example, and that is equal to by animate float as state, where the target value is then dependent on whether we're scaled down. If we're scaled down, then we could say, hey, 0f additional scale, and otherwise 1f of additional scale. So 100% of additional scale if the animation has finished. And now, if we assign this here, before actually drawing the background, that is important, by giving this a graphics layer modifier, which can be used to just animate the scale, rotation, translation, also visual properties like the alpha value here of this composable, then we could assign this here by setting this, so the boxes scale y and scale x, to 1f, so always at least 100%. And additionally, we add our animation progress here, which we also do for the scale y. So we evenly scale this in both dimensions. So this, as of now, is really just a completely normal animation. If we now draw this box here somewhere and maybe also center it inside of another box, so we say modifier is modifier, maybe fill max size. We apply our inner padding here to consider those window insets. And then we give this a content alignment of alignment.center to just center our red box inside here. Then we can say motion physics demo, and we launch this just to give you a demo of how this would now look like. Running devices, let's move this over here. And here's my pixel. There we go, here's our red box. By the way, we need something that triggers our animation that switches this is scaled down boolean to false or to true, depending on what it is. So let's quickly give this box a clickable modifier so we can click it in order to toggle this animation. So when we click it, we simply say is scaled down is the same boolean negated. Let's relaunch this once more. And if we now click this box here, well, then it will scale up. And take a close look at the animation. There is no overshoot effect being applied right now because it's a completely normal animation, and the default of all those Compose animation APIs don't use this new expressive way of doing it. If we want them to use this new expressive way of doing it, then we need to define an animation spec. So an animation spec, in case you're not aware, is in the end just a way to configure how your animation is really looking like. So you can define the easing, how fast it plays at specific points of the animation timeline. You can define how long it should take and so on. But we don't need to define these details because those details come from our Material3 theme now, since we've defined that here in theme KT that we use MotionScheme Expressive. And this already brings all those details for our different types of animations. So what we want here is, we want to now reference a material theme value. So just like referencing a color from our Material3 theme, we can now reference an animation style from it. So we can say material theme, MotionScheme, and here we now have different types of these animation specs that we could assign. So on the one hand, we have those spatial animations, so fast spatial, slow spatial, default spatial. And on the other hand, we have those effect types of animations, also with all those speed variants. Spatial animations are in the end what you should use if you are animating something that really changes something about the object's geometry. So scaling it up, resizing it, morphing its shape. That's also a new type of animation that the new Expressive theme often plays with. Moving it somewhere, so anything that really changes something about the bounds, about the scale, about the position of a composable, of a UI component, that should use the spatial spec. If you're, however, animating non-spatial properties, so for example, the color of an element, so you would animate the red color here to a green one, then that is considered an effect. And in that case, you should either use the fast, slow, or default effect spec. Now, there are also rules behind which speed of animation you should use in which case. Starting with the slow speed, that is really what you should use if the animation has quite a big impact on the screen. So for example, a full screen animation of something transitioning into a new screen. That is where a slow animation makes sense because the user just has to understand what currently happens. The fast spatial spec is therefore the counterpart of this slow animation. So here We don't talk about filling the whole screen with an animation, but about all those little animations where maybe a little icon appears and you animate that in, or maybe a little text moves a slightly bit to the right because that icon appearing. So this will just be an animation that plays a bit faster. And in between, we then have this default spatial spec, which is not fast, not slow, but somewhere in between. This should be used according to the docs for animations that partially cover the screen. Best example here would be a bottom sheet that doesn't necessarily fill the entire screen, but maybe half of it. So choosing the right type of animation here and the right speed of animations really has an impact not only on the look of your UI, but also on the usability of it to the user, so they understand what's happening and where something is happening. Because if something animates in, then our eyes are actually working that way to detect these things better because something is moving, something is happening, than if we just show a composable UI component without any sort of animation. In our case, because we have a little box here and we just scale this up a little bit here, that is not a very major animation on the screen, so I would say we use this fast spatial spec here. And we also need to opt into those experimental APIs here without enter, and then adding this annotation here at the top. And if we now relaunch this with this new fast spatial spec scheme, and we now tap on this box, then you can see there is a little overshoot. So it's a little bit bouncy type of animation now. If you would choose the slow spatial spec here, well, then this animation will in the end just play slower, which I think wouldn't be the right thing for this type of box that we animate here, but just to show you these differences. So you don't have to think about defining these details about how long this animation takes, what the easing function is, so how the overshoot effect looks like in this case, but you really just reference these values from your material theme. And if at some point you say, hey, I actually don't like this expressive type of animations, then you just need to go to your theme and you switch this to standard. And the moment you switch this to standard, then you go in here, then you can see now you don't have this bounciness anymore because you have kind of overridden this for the entire project as long as you always reference this MotionScheme. And that is how this new motion system for Material3 Expressive really works and is meant to be used. It's very important to mention here that all those Material3 Expressive components, so those components that have been adjusted to this new extension of Material3, already use and reference this MotionScheme value from your material theme. So a lot of these motion-specific animations you actually don't have to define on your own because the existing Material3 components already make use of that, and they will already have this bouncy effect naturally. But since they still reference this MotionScheme here from your own theme, you could technically still control whether you want this bounciness or whether you just want a plain normal animation by using this standard scheme here. I will put this back to the expressive scheme because that is of course what we want to get into this playlist here. But long story short, it's important to understand that this new MotionScheme here exists, and if you have custom types of animations, then these should now stick to the animation spec that you've actually chosen in your theme, and you shouldn't create a new animation spec here. So you could of course also say you define a tween here with your own duration millis, say this goes over a second, define your own easing function and so on, which may sometimes be necessary for very custom animations that aren't that related to maybe changing the bounds of something or moving something around. But in most cases, your animation specs that you use in your app should use one of these values that you can get from your material theme, as I mentioned, MotionScheme, and then one of these, depending on what type of animation you actually have. That's all I think matters for the motion system. So in the next video, we will start to get into new components. If you want to learn with our premium content, then down below you'll find a link to our website. Now that, thanks for watching. I will see you back in the next Material3 Expressive video. Have an amazing rest of your week. Bye bye.